So here we have a so-called inclined plane problem. No friction. So let's have a look and see what this question looks like. So the question gives us part of the diagram, but I'm going to complete the diagram by adding the additional forces that we need. The normal reaction at right angles to the plane, and the force of gravity on the 20 kilo mass, which is 20 g newtons. So let's have a look at finding the acceleration of the 20 kilo mass, and that's part A. And for this, what I'm going to do is resolve up the plane. So the normal reaction doesn't have a component in the direction of the plane because it's at right angles to the plane. The 18 Newton force has a component parallel to the plane, which is 18 cos 23. And the 20 G Newton force has a component parallel to the plane, which is 20 G sine 10. So therefore 18 cos 23 minus 20g sine 10, that's the resultant force, equals mass times acceleration up the plane. So using that equation, we can calculate the value of A, which is negative 0.87 meters per second. So that means that the acceleration is down the plane. So the mass is accelerating down the plane or the slope. Okay, what about part B now? The magnitude of the normal reaction. So for this, what I need to do is resolve perpendicular to the plane. Now all three forces have got a component perpendicular to the plane. We've got the normal reaction, which is already perpendicular to the plane. The 18 Newton force has got a component perpendicular to the plane, which is in the opposite direction to the normal reaction. That's 18 sine 23. And the 20 G force has got a component perpendicular to the plane, which is 20 G cos 10. So R minus 18 sine 23 minus 20g cos 10 equals mass times acceleration again, but this time the acceleration in that direction, perpendicular to the plane, is 0. So from that, we calculate the value of R, which is 200 newtons. So there we are.